All right, and our last speaker is here across the street. He is the professor of pediatrics, UC Irvine Chief, Pediatric Pulmonology Division, and the founding director of the Institute for Clinical Translational Science, and the program director of the UC Irvine Clinical Research Center. So long title, short name, Dr. Dan Cooper.
The first slide was the original scheduling of this talk, and it had me at 11:45 p.m. to 11 a.m. So I thought that you guys were trying to give me a message, which was either that I would talk for 12 hours, which everybody who knows me was easy for me to do, and I have 280 slides, Sean, if you want me to go on. I'm happy to do that. Or that I should talk about time technology, which is actually very, very useful. So I did come up with some time technology that I think illustrate the point about new technology. And the first is this one. When you're thinking about new technologies, as this illustrates, the technology has to be really accepted as this particular time machine was for this group of people, for those of you who saw that film. The other one is you really need to understand, this is another example of time technology that could help us deal with this, either going back or forward in time. You really need to understand the underpinnings, and in this case, the mechanism was lost completely. And then the third illustration of where technology is really, really important is in this time machine, where when the DeLorean company was ended, the ability to access the technology was gone. So the relationship to industry is very, very important. So I wanted to make those points about time. This is a little bit about me. This is just before I started doing this talk, which really got my hair all gray. And the reason I wanted to bring this out is because my research is about physical activity and health in children. And so I'm very interested in non-invasive techniques because we have to be non-invasive. I'm interested in the community as a whole because when you take care of kids, you have to be. And one of my other jobs is, as Sean mentioned, that I'm the head of our Clinical Translational Science Award, which is part of the NIH, and it's a really wonderful effort to speed up the process whereby we go from basic science discoveries to actual implementation. And this is, for somebody like me, a physician, clinician, researcher, is really what my whole career has been about. And so I say this because, I look at every, the hammer looks at every problem as a nail. So the two technologies that I want to talk to you about are things that I know about and that may have some application to this really profound crisis. And I'm going to talk about two relevant technologies. This is a picture at the top here. This is Sherry Rowland, who won the Nobel Prize in 1995 he's the guy who discovered the mechanism of the loss of ozone in the atmosphere. He is he is a chemist, and he studied volatile organic compounds. And a lot of his work has been translated now into clinical application in looking at human breath. And we'll talk about how human breath detection and monitoring might be something that's very useful. And the second was BC mentioned the use of mobile technologies and real-world monitoring, such as physical activity and sleep, has a great deal of relevance and something that all of you might be interested as you think your great thoughts in the next 48 hours. Sean began this whole discussion with this idea that anything that we do, including implementation of technologies in new applications, demands multidisciplinarity. And what I wanted to show you, this is sort of my experience with that. A paper we wrote about breath oxygen isotopic fractionation, something I'm very proud of because it came from the Division of Respiratory and Critical Care, the Department of Pediatrics at Harbor UCLA, and the Division of Geological and Planetary Sciences from Caltech. So to do translational work, you really have to cross boundaries and cross borders. This is a device that I found that was developed at the Karolinska Institute. It's called the SenseAbuse. And what it does is it makes available substances from human breath that you can then analyze for the presence of drugs. So the interesting thing about this is there's two sources of materials in human breath. One is volatile organic compounds themselves, which, as I mentioned, Sherry Rowland and other UCI investigators and people throughout the world have been able to measure now in the parts per billion and parts per trillion. Just so you know, there are about 3,000 or 4,000 gases that we emit every time we breathe, and they reflect our environment, and they reflect, in many cases, the medicines we take. What this device did, which is so interesting, it captured the other component of the human breath, which is the bioaerosols, which are sometimes in liquid form. And this device, which is handheld and you can see, actually captures enough quantities of the liquid form that you can then use it through gas chromatography, liquid chromatography, and then subsequently mass spectroscopy to actually measure substances. So here's a fairly recent article that looked at a liquid chromatography and tandem mass spec method to determine 28 non-volatile drugs of abuse in the exhaled breath. So this is from that liquefied bioaerosol that they captured in that device that I just showed you in the breath. And just some examples are shown here. You get really distinct signals. This is the beauty of mass spectroscopy, one of the great advances in the past 100 years or so. And the authors wrote, the method presented here, this is from 2017, is a well-validated analytical method based on chromatographic separation and mass spectrometric analyzer for analyzing drugs of abuse in human breath, and successfully analyzed real breath samples from patients. So in considering possible technological advances, this is certainly one to think of. This is from also another recent review from appropriately the Journal of Breath Research, which looked at a review of drug detection in the breath using non-invasive assessment of illicit pharmaceuticals. What I wanted to show you is some of the drugs that we've mentioned today, codeine, morphine, et cetera, all these opioids are detectable, some in particles, some, for example, fentanyl in the gas phase. And these technologies are there, but they need to be developed. And I think you can see the application of them. You know, we, in my world, as a pediatrician, a pediatric pulmonologist, I want to know if you're using your asthma medications, which are all inhaled now. And we have a method of looking in the breath to see if the evidence of the aerosol is there. And so we're now able to say, in an asthmatic patient, people rarely remember when they've taken their medications. People who use opioids are either unwilling to tell you or don't remember when they use their medications. So this gives you some grounding as to the status of the individual at that moment. The other technology is the ability to monitor real-life activities. This is a study that we did back in 1995. We were trying to figure out how to assess physical activity in actual human children. And it was this is from direct observation, and it was a method that we gained from a couple of anthropologists, friends of mine, who were studying the hunting-gathering people of the pygmy people in the Ituri forest in Zaire in Africa. And physical anthropologists are really interested in energy expenditure. And what they did was they did direct observations. They sat there, and every 3 seconds, they recorded what people did. And we did this in a bunch of kids in Westwood. It was kind of creepy, doesn't it? We were following them around and stuff like that. So we converted it to energy expenditure, and this is what activity patterns look like in real life. Now, let's fast forward in time to more recent days. We now have remarkable ability with devices that you can wear that give you just as accurate, if not better, indicators of real-life physical activity. Now, why is this irrelevant? Because it's clear that both in terms of physical activity and sleep, people who are overusing the opioids are going to have very significant and perhaps what we call pathognomonic or diagnostic indicators that there's overuse. Here's a paper from 2014, Sleep Disturbances and Pain among individuals with prescription opioid dependence. Results indicate high rates of sleep impairment and poor sleep quality among prescription opioid-dependent individuals. Pain severity was significantly correlated with sleep quality. Now, if you're wearing a device and I'm seeing you're becoming physically inactive over a period of time, maybe we can become more intelligent about this, and it can alert the physician, gee, what is going on here? Something's wrong. Or with these same devices that you can wear on your wrist, you're able to deduce sleep patterns as well. I want to put a plug in because this is a real theme that we've been talking about. The concept of learning health systems. Learning health systems is a very novel way of how we can meld data science, clinical information, and the community to solve health problems. And this is a slide that comes to me from Charles Friedman, who is chairman of the Division of Learning Health Systems at the University of Michigan. And what I love about this is this shows the virtuous cycle of how we can use data. Some of the apps that you folks might develop today among physicians, the patients, the community, law enforcement, to really improve the situation. So we typically are stuck here in academia where we go from data to knowledge, we write a paper, and we think we're done. That's no longer the case. That can't be anymore. We need to also go from knowledge to performance. We have to take action, and we have to then complete this cycle by performance to data. And this is a learning health system, which is a model of continuous improvement. So as you develop your programs, think about how this is an iterative and a self-learning process. Here's an example of a study that's just coming out. This is the article that describes what they want to do. This is from 2018, just came out, using routinely collected data to understand and predict adverse outcomes in opioid agonist treatment. They call it the OAT study, Opioid Against Treatment Safety. We will use standard regression techniques to model the magnitude and risk factors for adverse outcomes, mortality, unplanned hospitalization, and emergency department presentation, and unplanned treatment cessation during and after OAT, and machine learning approaches to develop a risk prediction model. And that's the essence of a learning health system. So I want to end with that. We've heard various versions of this. Lillian Wald, one of the great public health nurses of the United States of America back in the 1910s and 1920s. The great aim of education is not knowledge, but action. I also want to add something. So I see a lot of young people here, and I think that Sean invited me because I'm probably the grayest hair here around. Two observations. One is, I trained as a physician at UC San Francisco between 1970 and 1974. It was one of the times of a great heroin epidemic in this country. And one of my rotations as a resident was in the alcohol and drug withdrawal and rehab unit. And I used to sit and spend a lot of time talking with drug addicts. And the cultural change that we have witnessed over the past 40 years is really reflected. When my generation, we did not treat opioids as any kind of great pal or any kind of great friend. And when you saw those clips of a physician saying how wonderful they were, it's kind of shameful. And you really see this cultural change. It just didn't happen. The second point I wanted to make is I hope everybody understands what a great job Sean and Claire have done with this particular symposium. I rarely have seen such a great selection of speakers, keeping us, I'm over, so I have to be over because I'm a professor, you see. So, I get thrown out of the university if I stayed within my time frame, right? But I did want to say that it is really remarkable, and I've sat through a lot of these things. I remember in the late 60s and 70s, we used to have these things called teach-ins. Probably never heard of them. Teach-ins would start at 4 or 5 in the afternoon, and they would go all the way through the next morning, and you would learn everything about a topic. This is a teach-in on steroids with the added advantage that you guys are going to come out with something that's actually going to help. And so I applaud these guys, and I think they deserve a big round of applause at this point.